Plastic waste is all around us every day. And today we're going to have a look quite deep into the question if 3D printing and recycling can help us there. This is Recreate the Future. Hi, Ronan.
How you doing, Manuel?
Very, very fine. Thanks so much for taking the time today.
No problem.
I know that you are quite busy, and it's always difficult to grasp you and to get you down. And today we have 30 minutes with you, and we're going to go all into 3D printing and how it's related to plastic recycling and recycled filaments. So
Super.
thanks so much. And maybe you just want to introduce yourself briefly.
Yeah, sure. My name is Ronan Hayes. I am, as you can probably tell, not from the Netherlands, so I'm actually an Irishman. I am one of the co-founders and co-CEO of Reflow. Reflow is a sustainable material development enterprise, which basically means we identify streams of plastic waste, then we transform them using engineering and recycling processes into material recipes that can deliver very specific high performance for certain applications in 3D printing. So yeah, I mean, that's a sort of a succinct summary, is it? I don't know.
Absolutely, that sounds perfect. So I think the most or the easiest way for everybody to understand it is basically like in our rooms back there where we have our 3D printers. Basically, there are piles of your filament stacked up there, and it's recycled FDM filament for the largest part, which is probably the core of the business, right?
Yeah, exactly. So really the process for us is the same. But we deliver our material recipes, are sustainable in the sense that they could be biodegradable recipes in basically two formats. So one is your filament. So this is your roll. Standard sized would be 1 kg, although you also have your larger 4 kg for your larger style printers. And then the other form in which we deliver the material would be in granule format. And what's interesting about that is both within FDM, but increasingly we're seeing more printers that could just run off the granules and don't need the filament. The filament I would consider to be almost like fishing line for someone that isn't that familiar with 3D printing. So yeah.
While you mention it, I think during the last Formnext, I have seen the granular printers quite being a hot topic. Is this the same that you are seeing also in basically your sales, that it's kind of transforming from a bit more from standard filament to the granular part?
Yeah, it's interesting. So Reflow started in 2016. So we've been at it a while. We're getting pretty old. And when we were starting, the only standard for FDM was filament. So it would be all on the rolls. There were a small number of people who had sort of experimental, very large devices where they were attempting to do direct pellet extrusion, but it was very niche. In the last 3 years, there's been an explosion as a large number of engineering and printer manufacturers attempt to get the scale at which you can use direct pellet extrusion smaller and smaller and smaller, so that you could have a conceivable small enterprise or even desktop printer that can run just on granules. It's still probably not quite there. The price of the machines that can process just granules are probably out of the price range of most small businesses or individuals, but it will get there. And basically the trade-off up to now has been the exact level of detail or precision which these printers can do versus scale. So if I want to print, a big piece of outdoor furniture, some of these larger direct pellet printers are perfect. If I wanted to print a model like some of the guys behind me, small in that level of detail, they wouldn't be appropriate because of the nozzle size and the amount of material they deposit. But I guess the advantage of them would be, and this is why people are working on it, you completely skip the step of filament extrusion and production.
Yeah. Which and I had the chance to visit your production, which is probably just from a square meter share, which is the largest part in your production, right?
Yeah, I mean, the core thing for our factory is basically we operate 3 commercial large scale extrusion lines, soon going to increase in number. But the other major component of it would be our material analysis, quality intake, quality testing. That's really the core, interestingly enough, the core focus of the business. When you're working with recycled streams, being able to stabilize between batches, being able to substitute between streams from different recyclers, our material collectors to produce a homogeneous product. That's actually the secret sauce of Reflow. Filament was the output because it is the most popular output, and extrusion teaches you the same lessons, whether it's whether you're producing it for actually to produce filament or you're testing the material. It's still an effective way to evaluate the material. So it is still the largest part of our factory, and it is still the largest part of our commercial business. And I think that's how it's going to exist for the wider market in 3D printing, whereby over the next 10 or 12 or 13 years, it's not that filament printers will disappear, because they won't, because there's so many of them already in existence and in circulation. But you'll see a phasing in of the pellet printers. And then the job will be to deliver the exact same recipes and colors and compounded materials in a smaller volume granular form.
Okay, I already noticed that with my question about granular, we switched from the we switched very deep into the niche questions. Maybe let's jump one step back.
We can edit this out. No worries.
Yeah, we're just gonna put it to the back. No, don't bother. Let's go one step back. About starting with a problem, because I think nobody needs to discuss anymore that we're quite deep already into the plastic crisis, and basically everybody, I think it's common knowledge meanwhile that we have a huge problem. So therefore I think the more interesting part is how, from your perspective, 3D printing can be one of the solutions with one of your approaches to tackling exactly that problem.
Yeah, I mean, the facts on the ground are still the same. They're getting worse, effectively, even though there's more consciousness around it. You've got 400 million tons of virgin plastic being produced every year, less than 9% or 8%. So,
just jumping into, you said virgin plastic, because whenever I talk with you, I always hear that term. So you first of all differentiate between virgin plastic and recycled plastic.
Exactly, yeah. Virgin plastic is novel plastic, which is produced typically using fossil fuels, and that would be virgin, first time, exactly clean polymer, no thermal degradation. That would be virgin material. Yeah, it's unusual that the term caught on that way, but
no, absolutely. I just want to, for everybody who's not so deep into plastic recycling, just to clarify on the terms. So, based on your model, you take virgin plastic after being used, being disposed, as kind of the natural resource to start with your process, right?
Yeah, so they're producing 400 million tons of the new plastic or virgin plastic every year. Less than 9% is recycled, and most of it's single use. Most of it ends up in habitats in the sea, in our oceans, in our air, in our blood supply, in our food supply. So we're in that 9%, right? And our belief is essentially that while there is no simple solution for this, because plastic is it is both a polluting material, but it also is extremely important material for human beings. We don't really believe in evil materials. We sort of believe that it's responsible. Humans are responsible. Human systems are responsible for carefully managing which material for which application. So, I mean, if we look at the list of plastics that we use, there are some that should just be eliminated because they are either toxic, they're non-recyclable, and then there are some which can be replaced with biomaterial alternatives, biodegradable alternatives, and then there are some which are many of the materials in 3D printing that can be recycled many, many, many times. So instead of taking novel plastic, which isn't really required, which both makes this pollution problem, but also produces, I mean, collectively, plastic production produces about 5% of greenhouse gases every year as well. Why not take the millions and millions of tons of plastic already in circulation and use that again and again and again, so that designers can basically create the same things they want to create to the same standard, but not be contributing to plastic pollution or carbon emissions. So, I mean, in a nutshell, that's sort of our mission. And I think what you'd have to distinguish is that a lot of people, when they say recycled, some companies, some of our competitors would say they are virgin producers. They produce new plastic. They have some production left over, and they will take that and they will call that recycled because it is essentially leftover material.
Yeah.
Now that's actually good. It's great that people are improving their efficiency of production in-house, but it's not what we do. We're constantly taking streams from organizations who come to us, or else we're going to recyclers and we're testing grade upon grade upon grade upon grade that are properly source traceable and certified from food packaging, from medical tray packaging, from fishing nets, from gowns, PP gowns, materials. So, I mean, the list of potential sources is endless.
Yeah.
Yeah.
I mean, the good part is your resource is definitely not the problem, and we're not coming to an end very soon because we have quite almost unlimited sources of those. No, but good that you mentioned it. So maybe let's understand it by example. So you said you can either come established brands come with some kind of internal waste stream to you, or you take it from a recycler. So let's maybe start with the first one to understand it. So if I with a brand come to you and how does it work? Do you deep dive into the production stream?
Yeah, we basically have a kind of a three-phase structure. First of all, this happened so organically because we were the only people who everybody thought we were whack jobs in 2016 and 17. I actually attended a plastics conference wearing a red shirt talking about how we could recycle waste from a waste site in Tanzania and turn it into material to compete with the market. And I remember looking down at about 100 men, primarily German and Dutch, who were all wearing suits going, who is this moron? So it's been a funny journey to see it really gain a traction. But so in 2017 and 18, because we started publishing that we were actually hitting the same standards as Virgin with recycled streams you could actually trace, companies like Ace and Tate and KLM, the airline, they had came to us and said, look, we have these massive streams of plastic waste. In many cases, they're in between post-industrial and post-consumer. Post-consumer being they've already been used for an activity and now they've been collected. Post-industrial being they have been diverted in the process of creating a product, typically. And these streams were good quality, they were consistent in their measure. What can you do with them? And so we developed a framework then, which would be three key steps. The first step is material intake and analysis. And that's where you're understanding essentially the properties of the material. Is it flexible? Is it strong? Does it have great UV resistance so you can put it out in sunlight for a long time? You're essentially doing a psychological intake on your polymer. And there's two broad categories that would be mechanical and thermal or chemical. And so you carry out the remit of tests on it using material analysis tools. And then that's your first step, sort of. So now you know what the potential of this material is. You can start to think already, what might its commercial value be in the market? What material might this be useful for? What type of designer would like to work with this material? And then your second step is to say, okay, I've collected a batch of this material and I got this performance, but now I need to take many representative samples from that stream to understand what variation I'm going to get between batches. Like, do they have contaminants? Do they have another material in there that they're not aware of? You're mapping the stream. You're
Yeah.
understanding the flow of material and what you can expect from it. And that's basically the activity you carry out from the first. And you work, at least we work very closely with our partner, because we feel like if you do that work without them in the first step, or if they don't pay for it, there's no involvement, there's no engagement with it. So it
Yeah.
isn't an exciting journey, and it probably won't be pursued as you continue. And then in your second phase, you're saying, okay, let's do this for real. We're going to collect, X amount from, sometimes multiple locations, multiple stores, or multiple manufacturing locations. And let's try to do a production run of this material. And we're going to try to find its running rates. We're going to try to see how it behaves. We're going to try to stamp out any issues we find with contaminants. And then we're going to take the material and we're going to give it to either our own internal printing team, or else find some really top end design partners from our ecosystem, because we do sell the materials to amazing designers like yourself,
Yeah.
and see what they think about the material. How are they finding it? Would they pay for it? What do they not like about it? What is printing well? And that's phase two. And then phase three is saying, okay, we've got this. Presuming 1 and 2 went well, we've got this. We've got a good material. We've got good consistent flows of it. We figured out the issues with it. We've cleaned it. We've got a good OEM, a processing partner. We've got the proof of the 3D printing market. They love it. They're doing it. Now let's recycle this ongoing. And that's sort of the commercial framework route. Yeah.
Nice. And what I really love also about the use cases that you've already on display, how well many brands are able to communicate it. Because, so many brands talk about sustainability and responsibility, and to a large extent, it's just greenwashing. But basically, for those brands, it's much easier to explain what they are doing, because it's so physical. It's not digital at all, because you have the waste stream, you have the process, and at the end, in the best case scenario, you have a new product which is basically made not just from new resources, but it also takes something out of the trash stream.
Yeah, absolutely. And I think in the process, just because something isn't appropriate for 3D printing doesn't mean that time is wasted. You now have classified your waste stream. You actually know its properties. And these properties are also applicable to other manufacturing methods, like injection molding. So for instance, when we worked with Ace and Tate, they had test lenses that hold your glasses in place. But of course, they're popped out in store when they arrive at the store. And people have prescriptions, etc. So they have tons and tons of test lens material, which is perfectly clean. It was just display material.
Yeah.
You can split these. There's multiple types of them, but essentially they have a material called PMMA, and that's an amazing material. It's used in greenhouses. It's got great UV properties. It's a perfect material, and it's not a very established 3D printing material, for a variety of reasons, which probably are too detailed. But we both developed the material for 3D printing, and then in the process also realized that it could be used for injection molding, and was an excellent material for injection molding. So they actually produced their cases for their glasses from this material. So when you go down this journey of trying to understand the properties of the materials that you work with, it's never wasted if you're actually learning the lessons from the analysis and you're doing it systematically.
Yeah. Okay, I think I've kind of understood what the process on the brand internal waste stream looks like.
Yeah.
But I think the biggest part also for users out there is probably the part from the waste companies and their streams, which is probably used for the regular filament of your range.
Yeah, we've used both. And so it's a pretty Reflow is essentially a conduit where we're really connecting to all of these nodes. We're connecting to material science, we're connecting to 3D printing, we're connecting to recyclers, we're connecting to compounders, and we're sort of, because they have such large volumes of material recyclers. Most of the recyclers we work with are working off, hundreds and hundreds of tons per week or month. So the applications for 3D printing weren't their focus. They're not spending enormous amounts of detail to figure out if grade 1 or grade 16 is
Yeah.
really good for, printing bench sheets. That's kind of not that's not their focus. So that's sort of where we had come in. So for the other approach where someone hasn't come to us with the stream, we're essentially going to all of the top certified recyclers in Europe. We're focused pretty much in Europe because we think material should be local to local, but we have worked with streams elsewhere. And we're constantly checking new grades of material they have, constantly trying to understand, could they be used for this? If they can't be used initially, could they be blended using the process of compounding? So that's when we take a relatively degraded recycled polymer and we combine it with fiber, whether
Mm.
that's a natural fiber like hemp or a recycled fiber, as we're soon to launch. So are you adding an additive to it? So you're taking something which is 100% recycled and you're bringing it down to 99 or 98, but you're making it infinitely better to print with. And ultimately, that's what matters, because if I have the most pure material, it's not being touched, it's exactly the trash as it came from, let's say, post-consumer municipal waste, but it doesn't print, nobody's going to buy it.
Yeah.
So this is the trade-off in understanding how a grade will perform in the actual printing, in the printing application.
And is this also the same system where basically the fishing net material came from? Because I think you've launched it last year or beginning of this year, and I think it was a PP filament. So I think we haven't tested it yet, but I loved basically all of the applications of it because it has this color that really reminds you of fishing nets if you see them somewhere in the harbor
Yeah.
or so.
Yeah, it is actually, there's no coloring added to it. So it is
Okay.
the exact color of the fishing nets, which is cool. Yeah, that was an exciting one for us. It's pretty funny. In plastic recycling, ocean material is sort of the holy grail.
Yeah.
Probably because the marketing is so emotive that people it's very difficult to relate to the issue of like plastic pollution unless you see something pretty outlandish. But when people inherently see fish choking or dying in heaps of ghost nets or plastic in the sea, that's something that lands with people emotionally. So, I mean, honestly, recycling can occur in the ocean or can happen more upstream before it gets there. So,
Yeah.
it's funny that the ocean-based material is necessarily the one that people think, but I get it. We all have quirks like this. Um, but we wanted to develop essentially a recycled material that was tackling pollution in the ocean. We screened around 6 different recycled PP and PA materials, PA being nylon, and that's the other material using fishing nets
Mhm.
typically. And this was the one that we felt most confident about based on our testing. Polypropylene is quite a tricky material. I think for the kind of experienced 3D printing users who listen to this, if they listen to this, they will know it's subject to warping, expands in
Mhm.
shape, and so like if you're dealing with that, and then on top of that you're dealing with a lot of contaminants, again, nobody's going to buy it. So what we wanted was to find a really, really good consistent stream and to work with a partner that was had a really scalable process and had really good contracts with the fishing ecosystem so that they could guarantee their supply of polypropylene for 2-3 years. And then the second step we did was we blended it with glass fiber, which again, to some people might be, oh, questionable. Why are you taking this material that's recycled? That's excellent, but you're adding a synthetic fiber to it. For us, it's about the value of the material. So glass fiber reduces warping. That's the main challenge with that material. Glass fiber increases strength. And essentially what you're doing is taking a material that was degraded, which, literally fishermen have to be incentivized to stop just throwing them in the sea because they're useless otherwise, and from their perspective. And you're taking it and you're bouncing it up to a material that almost has kind of engineering grade properties. So it can be used for load bearing applications, chairs, furniture, stuff like this. And so in that regard, we just thought, you want this material to last for a long time. The application it's going to be used for, you're going to use it for a long time. So I think that would point to another topic, which is basically that sustainability is not a monolith. So like Sometimes sustainability means materials that disappear quickly, that are
Mm.
compostable or biodegradable. Sometimes it means materials that actually last forever, but everybody knows that, so they put them to applications where it will last forever, you know, and it's very durable and it can withstand the elements, etc. Automotive would be an example of an endpoint use case like this. And then the third category would be we want to endlessly recycle it. And there's materials that can fit in all of those buckets. That would be our perspective.
Okay. Um, Now I understood that I definitely need to try the material here. But maybe with having a look to the clock, let's jump into
Was that a
discuss.
tangent again? Was it?
Yeah, yeah.
Very boring.
We're trying to get to 30 minutes.
Okay.
No, but a question we often get, because we I think for the majority of our products, we have like a PDF and there's like printing recommendations, and we always recommend a recycled filament from you guys,
Yep.
because we really really like them. And we think that especially for the consumer part, we don't see many applications that need virgin plastic. So I think there we're both on the same side. But very often we get the question about the price of recycled FDM filament. Maybe you can give us a brief overview how it compares up to virgin plastic filament quality and price wise currently.
Yeah. So, I mean, when we started, we had a bunch of post-consumer plastic streams that we were going to launch as products, and we opted not to because from the very first time we launched a product, we wanted it to be as good as premium virgin materials because we'd seen the results. So we didn't want people to have to take a compromise on quality or in price to choose recycled. Now, unfortunately, if you compare several categories in the market, you have the top premium end of the 3D printing FDM market. If you're a BASF, you're ColorFab. These guys are so established. They've been doing it for a long time. They have massive factories. They've got great investment, great automation. Of course, they're going to have economies of scale and advantages in the quality process when as against a smaller producer like us. So that's one thing to think about. They're premiumly priced, sort of on reputation. We're priced probably just below them, because we have this extra massive step and activity, which is sourcing, finding, qualifying, and making sure it's consistent, um, for every stream, for every batch. So we have more work to do there, but we're trying to stay in between them and say your budget grade. So your economy filament, which is coming from, in many cases Asia, sort of not really sure what the process is, maybe sometimes variable in quality, although some of them aren't, some of them are great. No focus on sustainability whatsoever. And we're not trying to compete with them because we can't. And we don't think that's what we want to do. If we commoditize materials for 3D printing, none of it will be sustainable. It will be cheap, but we'll have more plastic pollution. That's how it will work. Yeah.
Yeah, absolutely. It was really funny because couple of podcasts ago, I was talking with Alle Spöhm, and
Yeah.
we also got to the point that sustainability, especially when it comes to 3D printing in the first place, is that people start questioning if they should really print whatever they are able to do,
Yeah.
and to reduce in the first place. So, but
Yeah.
I mean, honestly, I mean, especially from our price comparison, I think there is almost no premium anymore when it comes to the recycled part of it, especially if you compare it to the market price
Yeah.
of comparable materials.
I would say we just, what we're doing at the moment is because we feel there's EU regulation coming that's going to change the market a little bit in terms of expectations of recycled content for all manufacturing, not just 3D printing. And we are advancing our systems so that we can produce a higher quality product from more degraded streams. So everybody loves the very clean post-industrial stream that has good traceability, and really whoever's producing it can only use plastic. Let's say in the case of sterilizing medical tray, instruments in hospitals, they have to use plastic. So why not use that stream? It's perfect. Everybody would like that stream, but does everybody want to work with a stream that's mixed and that's post-consumer, but if you had a really good sorting and filtration system, or that you actually could produce sometimes material of the same standard. And you constantly have to be pushing that effort so that you can make a higher quality product from a more inferior stream. That's sort of a focus of ours right now. Yeah. But I think in terms
Um,
of pricing, yeah, I would agree. I'd say at the moment we're probably neck on neck, hopefully in terms of quality. That's our goal in terms of quality and price. We neck on neck
yeah.
market leader. Yeah.
Uh, Whenever people ask us for recommendations, I say there is basically no reason not to buy it, because at the end of the day, price is the same, quality is the same, or even better to what you get comparably. And at the end of the day, it's basically the right choice to do so. And if you don't have any negativities, it's, for me, it's always a no-brainer. And I'm
Yeah.
still very often shocked how many people don't consider it yet. Although, of course, it's getting a bigger and bigger topic.
Yeah.
But yeah, maybe to have a small look into the future, like based on the outlook. What are the things that are um, basically coming, that you are seeing on the recycled filament side when it comes to materials? So what are the trends in that area that basically we can all be happy to watch, to see?
Yeah, I mean, I'd probably say there, broadly speaking, maybe three. First of all, I think the area of natural fiber composites is going to become really, really important. So natural fiber, again, a composite would be a blend of a base
Mhm.
thermoplastic, a recycled thermoplastic in our case. It's been combined with a fiber to give it new properties that makes it infinitely more valuable uh, to the designer endpoint application. And we think materials like hemp and flax have massive capability here. Hopefully, we've got something coming later this year in this regard. And we're in the Netherlands, so to have a hemp material composite would be it would fit, right? It would be good.
Kind of natural.
Yeah. Um, so, and also if you print it, there's a smell from it. No, that's not true. Made that up. The second one would be biodegradable materials, truly compostable biodegradable
Yeah.
materials. So PHA is of strong interest here, and can be blended with PLA. Some sort of an issue which a lot of people have pointed out, but sometimes sort of angrily on the internet, is that PLA actually takes quite a long time to break down naturally, and needs to be typically assisted industrially at a plant, which you could still get out of the material and do so, but that is a very good point. So compostable materials. And then for Reflow, something we've been working on for a while is take back programs. So it's great to
Yeah.
have materials that are recycled. Already there's a massive cut in greenhouse gas emissions. You're already taking off plastic pollution. You're taking that out of society. But the next step would be then to take those materials back again from customers, provided it's of suitable volume, because there's no point doing it. You're going to almost use as much footprint to take back loads of small, 1 kg rolls. But if you have a lot of medium-sized businesses who are using lots of material and it's homogeneous material type, take it back, bring it through another cycle, sell it again.
Yeah.
So those would be the three that we're focused on at the moment. But I mean, the world of material science and 3D printing, it moves quickly. So
Yeah, absolutely. No, but jumping in on your point of take back problems,
yeah,
we whenever we talk with brands at Enable 3D, we always bring up the point that the best point for a repurchase of a customer is when a product is broken down. And I always love the idea of take back programs where you basically take the full product back, because this is the exact moment where somebody has a new need for a product or service to be served. And on the one side, you can you have the perfect loop, because you get all of the materials back into your system, where with a partner like you, it can be like really, really cool project. And on the other side, this is exactly the point where somebody needs to buy again.
yeah,
And it's basically like a natural loyalty program. And I completely don't understand why not more and more brands are working on this, and basically trying to understand when to close the loop on the life cycle, to start the next life cycle of the product and the customer. So I really like.
Yeah, I mean, I think most people who have seen some version of it are, when they think about it, it feels right. It's sort of like the antithesis of forced obsolescence. You know what I mean? Like this kind of thing when, like, let's say your laptop is damaged and you bring it and they're like, oh, there's no point, buy a new one. That feels wrong. You know what I mean? I think if you're not, like, if you're a conscious observer, you don't even have to be particularly interested in sustainability or like, but it's just, it's wrong. It's like, what a waste. So I couldn't agree more to it. I do think the reason more people don't do it is because setting the systems up initially
Yeah.
is a big undertaking. And I still, for a lot of companies, they might have, small enough teams. It's been, a difficult few years. They might have one person in sustainability or two people in sustainability. And actually the question is, and they need to be working inherently with the actual product team and production, because otherwise it's not going to make sense commercially unless it's really ingrained in how they do things typically. So I think you will see glowing examples coming about very soon. But I think people see them, they love the idea of them, and then they think, gosh, this is too much work. I think that's what happens basically. Yeah.
All right, Ronan. Let's get to the almost last question. So basically, based on your perspective, and you are really deep into the field of plastic recycling, and then at the end of the day, making it to 3D printable material. What is a development that you are seeing that most of us, which are outside of this bubble, are currently completely underestimating?
I should have known this question was coming up sometime. I mean, because we're so focused on materials on our end, we miss the wider picture in the 3D printing. I mean, we've already talked about some of them, which is direct pellet extrusion, which is a portfolio of if for us, we're basically focused on proving that engineering grade materials at the top of the market that large engineering companies would use, that companies like Signify, etc., would use. We want them to be sustainable and to match the properties. So that would be the thing that we think is going to get broken soon. But in terms of 3D printing, I mean, I'm curious to see how AI impacts the actual success and adoption of 3D printing, because ever since I joined 3D printing, people have basically been saying, you think it's great, and then it's a pain in the arse. If they compare it to other manufacturing systems, like the failure rate is too high. I don't know if is it my design, is it the material, is it the printer? And I think that's going to be revolutionary. I've seen some stuff from collaborators like ours, like AI Build, who are, the concept of a print being corrected mid-print. And that means that a huge number of very large volume applications will go to 3D printing that used to not. Because if you're 3D printing a boat and the print fails in the last 30 minutes after spending 5 days, you're not going to come back to 3D printing very quickly. So the use of AI to massively increase efficiency in print, I think, is probably the one that to watch at the moment, or at least it's topical. As opposed to AI destroying the world, which is the other topic people are raising. So, yeah.
Let's just wait for that one. And then, final call. If somebody now with a company, with a non-waste stream understands, okay, maybe that's a really cool project to start. How to start a collaboration with you guys?
We have open forums on our website. We are still a small team, so we see most of them. I mean, truthfully, we don't get back to all of them, which I sometimes do feel bad about, because in the early days, if somebody was like, "Hey, I've got some waste in my room, will you recycle it?" You'd be like, "Maybe," and that's not how it works now. So we can be a little bit delayed in getting back to people, but we have a project collaboration forum on our site. And also in our shop, you can ask for direct contact with us, and that'll be picked up by a member of our commercial team. So we're pretty open in terms of communication, and maybe sometimes not as prompt these days at getting back to all of them, but that's going to improve as we grow.
All right. Perfect, Ronan. Thanks so much for this little journey into the world of plastic resourcing, plastic recycling,
Yeah.
and the easy and sometimes not so easy answers to simple sounding questions.
Yeah.
Thanks so much.
It's been an absolute pleasure. Thank you very much. Sorry if I went over your time limit.
No, I was already expecting that.